be analyzing solutions in context. They're going to be graphing systems of equations, using technology and just using traditional materials like a ruler and a straight edge, some sort of straight edge. Then they're going to be analyzing the solution and talking about constraints. What does the solution mean in the context of tying knots in a rope and measuring the length of the rope? Okay, so you guys are going to get two different strings. I put you in groups for a reason. It gets kind of hard to measure and hold down the string at the same time. So one of them is a hemp string. This is hemp. So if I were you, have one person hold it down and have one person measure it, okay? Even though you guys are sharing the data, I still expect you to individually do your own packets, okay? Also, as you know, these have been worn and torn, so please be gentle with them. We're using inches today, so I'm going to have you measure the nearest half inch. So for example, if I were 6.9 inches, what would be the nearest half inch? 7 inches. So when you're filling out your table, I don't want to see 6.23. I want to see 6 inches, okay? So remember, if you are lucky enough to have one of the two TA83s that we own, you are fine. But most of us have an 82 or 73. So for the regression part, I think that's number 7. They're going to ask you to, what's the point of intersection? So you're going to have to come up to PJ and type it into decimals. So if you're going to have two different equations, one equation for the hemp, one equation for the baby blue rope. Type it into decimals, and that'll tell you the point of intersection. You can also access decimals there in the center or there on the cart. So that's not until you get to number 7. I open up the lesson with a tie the knot activity with just one string. And so they were tying knots, and they were seeing if there's a linear relationship between the number of knots you tie and the length of the string. And that was kind of like an intro to the system, because at the end, I posed questions like, well, what if we tied a longer string? Would they ever be the same length? What if we tied a shorter string? Would they ever be the same length? What if we tied a thicker string? Would they ever be the same length? And so kind of get them thinking about, well, that's where we're headed.
Oh, okay, which one do you want us to put for the graph?
What this table of values, what do we do with tables of values?
You graph it.
We graph them, right? So this 0, 9 represents a what?
The XY.
The XY, what do we call an XY together when we put them on a coordinate plane? It's 2 words.
Linear equation.
No, not the linear equation. We want to graph this 0 and 9 together. What are they called together?
Graphing points.
Points or...
Points of graphs.
What's a fancy word for points?
Coordinates.
Coordinate.
Graphing coordinates.
Or ordered pairs.
Ordered pairs.
These are these are all the ordered pairs. So you want to graph these, and that'll be your hemp. And then graph these, and that'll be your baby blue string. And then sketch your line of best fit using a straight edge. What you did in your calculator is number 1. So you're right. You forgot to just graph them.
Okay, I got you.
So,
okay, everything makes sense now.
The main difference, I think, with linear functions in general in 8th grade is that certain vocab is different. So they talk about input and output. And in high school, we talk about domain and range. And we use more meaty vocab. Not to say that 8th grade vocab is not meaty, but so we're trying to get them to draw the connection. I graphed my hemp line, I graphed my baby blue line, and they met here. What does that point mean?
Why that's when they both. That's when they'll be the same length.
Yeah.
Oh, we're just gonna say that.
That's it. Kids are taught how to measure in the elementary years, and so that was something that I didn't think that I would have to even worry about. But when we did the tie the knot in the beginning, there's a lot of issues with using rulers. Kids didn't know how to use a ruler. Some kids had never even held a tape measure before. And so that was something that if I would have checked what the years before, they could have, oh, by the way, we didn't have time to work on measuring. They're not really strong at it. That could have been something I predicted ahead of time. And then we could have made accommodations like measuring to the nearest half inch or nearest centimeter, things like that. So it's definitely necessary to look ahead to see if you're doing is going to help out the year after you and look before.
That's what we got. All right, y'all work with y'all.
So we have done plenty of practice with, like I mentioned earlier, nice clean tables. So students were looking at tables or sets of ordered pairs or mappings or data from surveys, and they were practicing typing it into the calculators and running regression and writing out the equation and explaining what does this equation mean. If you get y equals 0.25x plus 24, what does it mean in the context of number of knots and length of a string? So we practiced that a lot. Every single day I would come back to it at the end. Okay, we got this equation. What does it mean? Even if we were just doing journal procedural problems, even if we just got a basic problem like y equals 2x plus 5, someone tell me a story about what this can mean if this represents my bank account. How much money am I starting with? How much money am I increasing? How do I know that I'm increasing? How do I know that I'm not decreasing? Questions like that. That way, when they get to something like this, they're not like, you never taught this to me, because they're gonna say that, because you shouldn't be teaching directly how to do this problem. They should be able to stretch their thinking. The thing about students with autism, or at least my students, very high functioning. So if you notice, I placed a laptop on his desk so he can go ahead and do the regression with Desmos by himself. I allowed him to work alone because he feels like working with others is holding him back, and so that was just something that I let him do. He didn't ask for help, and I looked at his packet at the end of the time. He didn't finish because he has to leave early, but everything he did up to that point was flawless.
This is like comfortable reading. This is like that.
Do you know?
Do what? What is F? If it's done. What? What do we do with the hair? Does that mean someone
No, okay, do you remember the ones where they cross
my
parallel?
socks are really hot in here, so I wasn't there that day. Because I got that dirt bike. I was sick.
Okay, look at
Come
those.
on,
You know that one solution, no solution. Which one? But okay. No solution. Don't look back there.
What would be the best way
What does that not connect with?
Yeah, so you just want to draw no solution?
Yeah. I was trying to make it.
At the end of the lesson, if students finish, hopefully they all finish, but there's going to be a quick little yellow exit slip, similar problems, new context. And so I think the problem's over the money in Jay-Z's account and Beyonce's account. And it's going to be two parallel lines. And so I'm going to ask them, will they ever have the same amount of money in the bank account at a given time? Hopefully, kids will realize that since these are parallel lines, they're never going to intersect, they're not going to have the same amount of money. And it should relate to what they got when they were doing the tie the knot, because they're going to have intersection points, because these strings eventually will be the same length after X amount of knots. It's going to be interesting, because at the end, after they finish it, they're going to place it wherever they think they're learning it. As I have a little stoplight system, so a green basket means I get it, I can teach it. Yellow basket means I think I get it, I'm just not too sure, I have a couple of questions, so you put it in that basket. And then the red one is something stopped my learning today. I am lost, I need help. And so it's interesting because some kids who do exercises completely wrong will place it in the green. I get it, I can teach it. And so that'll help me tomorrow say, hey, a lot of us put things in the green, but it wasn't right. So I'm glad you're confident, but let's be precise and confident at the same time. It's gonna help me decide what we're gonna cover tomorrow.
No, this. Yellow.
This. What? You have to do it. What do you mean? Again, if you didn't finish today, what do you do with it? Homework.
We did it. We did. The slope is 1. The slope is negative 1. I wouldn't get it. 1 to 1.
It's fun. It's actually interesting. Like there's like a bunch of games like every week.
Yeah.
And you like actually like want to get the problems done, so you can like do the things that are fun. So it's like a win-win.
I think this is the first year I've liked math, actually.
The goal is to give kids successful learning moments in mathematics, and that's honestly the easiest way for your kids are going to say, you're a cool teacher. You can try to be cool and hip, but if you give them successful moments in math, they're going to love you to the end because they haven't had many successful moments. That's just the reality of math in America. Math is easy for some and unapproachable for others, and so those others, you want to give them as many successful moments as you can.